Section 5 is all about metamorphic rocks. Now before we get started with the slides, there aren't that many because this is a pretty short section. Let's take a look at the bell ringer together. You'll notice that there are two pictures of rocks here. Both of them are metamorphic rocks. Which of these two do you think is an example of a foliated rock? What about a non-foliated rock? Which of these do you think is non-foliated? Now, the really important question is, how do we know the difference? What is the difference between the term foliated and the term non-foliated? That's where we're headed today. A foliated rock, as you'll learn in just a little bit, is a rock that has grains organized into bands. And so in this top example here, you see how the minerals have been organized or arranged into bands. That's an example of a foliated rock. A non-foliated rock has all of its grains arranged in a random pattern. And so in this sample at the bottom, you'll notice that we can't see those bands. It's non-foliated. The two objectives for Section 5 are to describe the conditions under which metamorphic rocks form and to identify the ways in which geologists classify metamorphic rocks. Now, the Geology Kitchen video on this slide is also on my website, so you'll have a chance to watch that later. Metamorphic rocks form through the exposure of intense heat and intense pressure. A metamorphic rock starts out as something else. It could start out as a sedimentary rock. It could start out as an igneous rock. Sometimes metamorphic rocks actually start out as other metamorphic rocks too. But what happens is that when that rock, whatever it is to start with, is exposed to lots and lots of heat, and we're talking like heat like the center of the earth hot, and lots of pressure, so lots and lots of layers of rocks piled on top of it and pushing down and in on all sides, that's going to stress the structure in the rock out, and it's going to cause it to melt, it's going to cause it to change, it's going to cause those grains to rearrange. When all is said and done, that rock that we started with is going to have a completely new appearance, it's going to have a completely new texture. Remember, that's the arrangement of all those particles. It's going to have a brand new crystal structure, and it's actually going to be made up of a different percentage of minerals as well. So where we saw lots of quartz perhaps in the first mineral, the mineral we started with, maybe we see lots and lots of halite or lots and lots of muscovite mica in the mineral that we end up with. Metamorphic rocks form in all sorts of different ways. Their appearances and textures and crystal structures, mineral contents are going to all be different, but they all form through intense heat and intense pressure. Geologists are going to classify metamorphic rocks based on how their grains are arranged. Now, we've talked a lot about grains. When we were talking about sedimentary rock, we used the word sediment to describe the grains. When we talked about igneous rock, we talked about how those grains were crystals that were cooling at different rates from molten material. Now, when we're talking about grains in a metamorphic rock, it could be either or, because remember, metamorphic rocks could start as sedimentary rocks, they could start as igneous rocks, or they could start as something else. The way that these grains, these particles or crystals that make the rock up, are arranged will tell us about what kind of metamorphic rock we're dealing with. Here are those terms again from our bell ringer slide. A metamorphic rock is either going to be foliated or non-foliated. Remember that if it's foliated, we're going to see those grains arranged in parallel bands or layers. So these two rock examples on the right or left-hand side of your screen, have their grains arranged in bands. In this example, this is schist. It's a little bit harder to see those grains, but they're there, the light and the dark. And in this example, same thing. Notice that we have light and dark, thicker bands, so they're a little bit easier to see. The word foliated comes from the Latin. In Latin, it means leaf. And you can kind of think of it as a bunch of leaves stacked one on top of another, a foliated metamorphic rock. On the other side, a non-foliated metamorphic rock has grains arranged in a random order. We don't see those examples of layers here in the marble and the quartzite on the right-hand side of the screen. Those particles are randomly arranged. As metamorphic rock is forming, remember that there is a lot of force, a lot of pressure being placed on that rock. And sometimes, instead of seeing nice flat bands like we did in the examples on the previous screen in a foliated rock, We might see deformation happening. Now, you've heard that word deformation before, the bending of rock when it gets really, really stressed. Deformation is going to cause changes in the way that the bands look because of the force placed on the rock. The screen here shows a number of examples of deformed foliated rock. It's important to notice that not every example of deformation is going to be this obvious. Sometimes the folds are so small or so fine that they're not visible to our eyes without some sort of magnification. Oops. Let's go the other way. There we go. Metamorphic rocks have a lot of practical uses. Marble and slate are probably the two most important, or certainly the two most well-known metamorphic rocks. Marble is a very important rock to us because it has a very fine and even grain. That means that it's easy to cut, and it's been easy to cut for a long time, even when humans didn't have as advanced of tools as we do today. And it's fairly easy to polish. And so for that reason, marble is often chosen to be used in sculptures, like this sculpture of Alexander the Great that you see on the screen here. And it's also often used in building decoration. Marble forms when limestone is exposed to very intense heat and pressure. And we talked a little bit in our sedimentary rock section about how limestone has been used in building too. Now, slate is a foliated metamorphic rock. That means that those grains are arranged in bands. Because of this, slate is fairly easy to break into flat pieces, sort of like the muscovite mica you were identifying when we were still in school was easy to break into thin, flat pieces. Slate is going to break in a similar way. And because of that, it's a really useful material for things like flooring. There's a picture of slate tiles on the screen here that you can see. It's used for roofing tiles as well. Some people have shingles on their roof that are made out of slate. It's used for outdoor walkways, and actually, it's what's used in chalkboards too. Kind of cool. Both marble and slate have been used for a really long time. Now, your homework due, not on Friday, but on Monday at 2 p.m. is going to be the homework form for Chapter 5, Section 5. Now, this is a fairly short section, but do put some time into that homework form so that you really understand the difference between metamorphic rocks and those other types of rocks that we've talked about in Chapter 5. There are some things for you to remember on the screen. You can go ahead and pause the video and read those through if you would like. Let me know if you have any questions.